In this video, we're going to be talking about something that may have been on your mind for a while. How do we take the square root of a negative number? Let's say -4, for example. So there are really not any real answers when we're talking about real numbers. Square root of 4 is 2, right? And if we square that, we get positive 4. If we square -2, we still get positive 4. So we can't square a number and get a negative number. So how do we take the square root of a negative number? Well, this is what we got to do. We got to use our imagination, and we're going to use what's called an imaginary number or an imaginary unit. And we use the letter I to give us that. So we gotta use an imaginary number here. Let's see how we do that here. Well, I has a couple of definitions. We can say that I is the square root of -1. And that will help us take the square root of a negative number. And we'll show you how to do that. If we can break something down or factor it down, so that we get -1 under a radical, then what we can do is we can take I out of the radical. Alright, so let's see if we can do that here. So if we have the square root of -5, we'll come back to this example here in a sec. Square root of -5 here. Well, if you remember, the law of square roots or radicals allows us to break up a number under a radical into two different radicals. So really -5 is the same as -1 times 5, right? And we're allowed to break that up into two different radicals. So the square root of -1 times the square root of 5. And if you remember the definition of I is the square root of -1. So what we do is we, instead of writing the square root of -1, we change it to an I. That's our imaginary number. And we multiply that by the square root of 5. Well, since we can't simplify the square root of 5 anymore, this is really how we write our answer. It's I times the square root of 5. So that's the square root of -5. If we could imagine an imaginary number, then we would multiply that by the square root of 5 and we would get the square root of -5. So that's how we use I. Let's do a couple more examples here just to get used to it. Let's take the square root of -4. And then we'll move on to some more complicated equations and expressions here. So again, break this down. This becomes -1 times 4. We can break that up into two different radicals. It's the square root of -1 times the square root of 4. And so what we do is we rewrite the square root of -1, that's I. We just write I instead. And then we write the square root of 4. Well, the square root of 4 is 2. And really, I times 2, well, unfortunately, this isn't the right order we need to write it in. We just got to write it in the right order. We always write our real numbers first, and then our imaginary numbers. So this is correct, it's just not in the correct form. So this is what we want to end up with, 2 times the square root of I. Alright. And now let's get into solving some equations here. Remember, simplifying is always getting the positive value. So in these two examples, I was just simplifying. But when we solve, when we want a variable equals, when we solve for a variable using square roots, we're always going to get a plus and a minus answer. So let's see what that looks like. Get rid of this. So let's solve this time. Now we're solving, so we want the positive and the negative answer. We want to know what number times itself, or what number squared equals -9. Well, real numbers can't get us there, but imaginary numbers can. So let's solve it. Let's do the square root of both sides. That always undoes a square. And we get x equals, anytime you take the square root of both sides when you're solving, just rewrite plus or minus right away, right next after the equal sign, all right? So then we got plus or minus the square root of negative 9. Let's rewrite that as plus or minus negative 1 times 9. Let's keep rewriting here. We'll start skipping this step in a little bit, but let's just get used to it for a while. So this is plus or minus the square root of negative 1 times the square root of 9. Let's rewrite the square root of negative 1 as I, so we got plus or minus I. And we'll rewrite the square root of 9 as 3. And then we just got to make sure we put it in the right order. So write the real number first, so plus or minus 3, and then the imaginary number last. So really this is two different answers, right? We got positive 3 times I, but we also have negative 3 times I. And if you remember what we're actually doing with quadratics, if we're solving a quadratic, we are solving for x, and that gives us the x-intercepts. So our parabola is crossing this imaginary plane now at 3i and negative 3i. And maybe someday we'll do a video on the complex plane, but that's not in the foreseeable future right now. Let's keep doing some more examples here. Keep getting more and more complex while we solve, using I and using square roots to solve quadratics. Let's do, where's my third example here? 2x squared plus 3 equals negative 13. So to solve for x, we always want to get x, or x squared in this case, all by itself first. So let's undo the operations around it. Let's undo that plus 3 by subtracting 3 from both sides. That leaves 2x squared equals negative 16. Let's undo the multiplication by 2 by dividing by 2. That leaves x squared equals negative 8. And now we can take the square root of both sides to undo that square there. So we get x equals plus or minus the square root of negative 8. Let's rewrite that as plus or minus the square root of negative 1 times the square root of 8. So let's simplify that. The square root of 8 is really the square root of 4 times 2, right? So let's take the square root of 4 out. Let's see if I can write it all as one line here. Let's try not to skip any steps. Plus or minus the square root of negative 1 times the square root of 4 times the square root of 2. That's really what the square root of 8, the square root of negative 8, is. We just broke it down into its factors and then rewrote it as a bunch of radicals. So now let's simplify. Instead of the square root of negative 1, we got I. Instead of the square root of 4, we get 2. And the square root of 2 can't be simplified anymore. So let's just rewrite it all in order. We want x equals plus or minus 2 first, then I, then the square root of 2. So really we got positive 2i times the square root of 2 and negative 2i times the square root of 2. Two answers. Alright, so it's getting more and more complicated here as we go. Let's do another one here. I'm going to try and shorten up my steps here, so see if you can hang with me on this one. Let's do 3x squared plus 10 equals negative 26. So undo the addition of 10 by subtracting 10. So that leaves 3x squared equals negative 36. Let's divide by 3. Undo that multiplication by 3. That leaves x squared equals negative 12. Let's take the square root of both sides to undo that square. So we got x is plus or minus square root of negative 12. Let's rewrite that as the square root of negative 1 times the square root of 4 times the square root of 3. If we were to multiply all these together, we would end up back at the square root of negative 12. So we just factored it. Let's rewrite everything we can here. Plus or minus I. Square root of 4 is 2, and we can't do anything with the square root of 3. We can't simplify it anymore. Let's rewrite it in order. So we got plus or minus 2I times the square root of 3. All right. So one thing you might notice here is, why do we have to rewrite this as the square root of -1 and then change it to I? You can take a shortcut here. You can actually say, if I'm taking the square root of a negative number, then why don't I just take out I to begin with and then simplify under the radical? So anytime you're taking the square root of a negative number, always you could just jump right to this step. Just take out the square root of -1 and rewrite it as I on the outside. You're allowed to do that, and then hop down to that step. That's possible. Let's see if we can do that on our next example. This will be our final example here. X minus 1 squared. So here we have a binomial squared. And that equals -7. So right off the bat, as long as we have the binomial squared by itself, we can undo that square by square rooting both sides. And that leaves plus or minus the square root of -7. Well, let's rewrite that as I on the outside, plus or minus in front. So the square root of -1 is I, and I just took that out. And then I can rewrite it as plus or minus I times the square root of 7. We still have x minus 1 on this side. So if we just add 1 to both sides, we're done. So what happens here? What order do we need to write this in? Well, this was plus or minus I times the square root of 7. If we add 1, you might think you added on over here, and that might be okay to do for a step. But really, the order we need to write it in is that real number 1 goes first, then we write everything else. And this right here will lead us into our next video. This is called the standard form of a complex number. And a complex number is where we have a real number added to an imaginary number, or subtracted. It doesn't matter, as long as we have something just like this, where we have a real number plus or minus an imaginary number. That is called a complex number, and we can actually do math with this using like terms and such. So that'll be the next video. Let's hold off on that. So just a heads up, this is called standard form, where we write the real number plus or minus the imaginary number. And this is called a complex number. And we will get to how to do math with complex numbers. And we'll continue to practice using this imaginary unit as well. So on to the next video.